This is a story of software developer that used to write code in Java and enjoy working a lot with enumerations to define a closed set of data. That same developer one day started to work with PHP and realized that they were missing enumerations, which grew quite a sadness in him. But finally, that developer is no longer sad since version 8.1 of PHP added enumerations to language. How does it work? Enums are similar to classes. It defines a new type which has a fixed, limited number of possible allowed values. This declaration creates a new simple enumerated type userState which has 4 valid values: userState register, userState activated, userState disabled, and userState blocked. A function may be type checked against an enumerated type, in which case only values of that type may be passed. A function may be type checked against an enumerated type, in which case only values of that type may be passed. By default, cases are not intrinsically backed by a scalar value, that is, userRegister is not equal to 0. Instead, each case is backed by a singleton object of that name. This type of case with no related data is called pure case, and an enum that contains only pure cases is called a pure enum. All cases have a read-only property name, that is case-sensitive name of the case itself. That is largely an implementation artifact, but may also be used for debugging purpose. What is backed enum? By default, enumeration cases have no scalar equivalent. However, there are cases where an enumeration case needs to be able to round trip to database or similar data store, so having a built-in scalar equivalent to defined intrinsically is useful. To define a scalar equivalent, there is a syntax. A case that has a scalar equivalent is called a backed case, and it is backed by a simpler value. An enum that contains all backed cases is called a backed enum. A backed enum may contain only backed cases. A pure enum may contain only pure cases. A backed enum may be backed by a type of integer or string, and a given enumeration supports only single type at a time. If an enumeration is marked having a scalar equivalent, then all cases must have a unique scalar equivalent defined explicitly. There are no auto-generated scalar equivalents. Value cases must be unique. Two backed enum cases can't have the same scalar equivalent. Value cases have an additional read-only property, value, which is a value specified in the definition. In order to enforce the value property as read-only, a variable can't be assigned as a reference to it. Backed enum implement as internal backed enum interface, which exposes two additional methods. From integer to string self, which will take a scalar and return corresponding enum case. If one is not found, it will throw a value error. This is mainly useful in cases where input scalar is trusted and missing enum value should be considered as an application stopping error. Try from integer to string self will take care of scalar and return the corresponding enum case. If one is not found, it will return null. This is mainly useful in cases where the input scalar is untrusted and the caller wants to implement their own error handling or default value logic. Enumerations may also have static methods. The use for static methods on the enumeration itself is primarily for alternative constructors. Static method may be private, public, or protected, although in practice, private and protected are equivalent as inheritance is not allowed. Both pure enum and backed enum implement as internal phases named unit enum. Unit enum includes a static method, cases, that returns a packed array of all defined cases in order of declaration. I hope that this video helps some of you figuring out the potential of enumerations. I think this has been a great addition to the language, and I'm curious to see how this new construct will be used to libraries that each one of us use each day to create great projects. Thanks for watching, and feel free to add comments about your experience.